Okay, so first request was this one, question 7. Write down the domain of f of x. This could easily be a non-calculated question. Most of it, anyway. So f of x is this. Sine x, you need to know this. You need to memorize what these graphs look like. Starts from here and just keeps oscillating like that. And it goes the other way as well. So the domain are the valid values of x. Well, they go on forever and ever that way and ever that way. It's valid for, infinite amount of distance to the right and to the left. In other words, it's valid for all real numbers of x, and we write that like that. So the domain is valid for all real values of x. So h of x is this one. Oops, don't want to be rubber, do I? Why is it still in the rubber mode? It's weird. No, it's not. Okay, so what you have to recognize here then is the coefficient of sine whatever is often the amplitude. Now, sometimes that value is negative, and the amplitude can't be negative because I hope you recall the amplitude for a sinusoidal graph is measured from the midline here, or the principal axis, to the maximum or the minimum. And because they're symmetrical, those distances are going to be the same. So that's the amplitude, and that's a distance, and that's always positive. However, depending upon where the graph starts, this value here can be negative or positive. But even if it was -3, the amplitude would still be 3. So this value, the coefficient of sine whatever, sine something x, gives you the amplitude. So you just need to be able to recognize that. So yeah, that gives you the the amplitude. So you just have to look at the coefficient here. And like I said, if it happens to be a negative number, which it can be sometimes, the amplitude would just be the positive equivalent, the modulus or absolute value. Right. What's the next one then? Oh, period. Right. Okay. So for period, you do have to recall the equation is 360, because we only work in degrees in this course. There is something called radians, which you'll do at IB level, divided by b, where a is the coefficient of sine or cos, whatever it is, and b is the coefficient of x, so the number in front of x, which you do need to recall. So you can link this pretty easily. So I can see here that the coefficient of x is 4, so all I have to do is, in order to find the period, do 360 divided by 4, which, as we all know, is 90. So pretty easy, actually. But you got to memorize these things. You have to. This is, you're not, so many of the formulae you're not given. Anyway, right. Describe fully a single transformation that maps the graph of f of x onto the graph of g of x. So please recall general rules for transformations, that if it's inside the brackets or inside the function, it affects x, and it does the opposite of what you think. So this, for example, would mean the x values would all go left. They would be a transformation or translation, of minus a, 0. So it only affects x. And same inside the brackets. This would mean all the x values are divided by a. But then when it's outside the brackets, which is what we're looking at here, or outside the function, it can be adding or subtracting. Now this would mean that if it's outside the brackets of the function, it affects y, and it goes up or down. The whole thing shifts up or down, and it does what you expect. So if you add a, it's going to go up by a, the whole graph, and then, or function, and then if you got, so you're multiplying outside the brackets, outside the function, then the y values are going to be multiplied by a. So going back to this, then, that means the y values are multiplied by 2. So if I'm going to describe that as a transformation, then let's go on to that other page. And say if the original sine graph is there, and then the new one, the y values have been stretched. Let's use a different color. So, oh god, that's in the way. say something like that. So it's still going through same x values, but look, the y values have been stretched. Now we should recognize that it's the nasty transformation that's new this year. So that is actually, it's a stretch from the invariant line, the x-axis. So the x-axis is the invariant line. And it's a stretch of 2. So it's been stretched from either way by 2, by scale factor. I'm going to write SF of 2. So that would be the transformation. Right. What the heck? Oh, okay. Describe fully a single transformation that maps y of f of x, so this one, onto, y of k of x. Well, I mean, that's actually pretty simple. So, but you got to recall what I was babbling on about before. So it's this. So it's inside the brackets. So it's affecting the x values. It does the opposite of what you think. So plus 60 means it shifts left by 60. So it's a translation. So it is a translation of, you'd write translation, it's a shift. And if you want to, secure the points 100% by vector, so can't remember which way around it was, I'm sorry, plus 60, so it's going to go the other way, right? So it affects x, so it's minus 60, 0. So translation by